Okay, we're going to try something different today, and you'll see how that difference is in just a second. So we're going to start with Chapter 9. This is Lecture 9.3, and our learning objectives are going to be we're going to continue solving general linear equations, and we're going to solve equations with fractions and decimals. So we'll be using the concept of LCD, identity, and no solution again. So I had the wrong screen up. Let's go to this screen. Same exact screen. So just to remind you, I don't know if you can read it right here, but the least common denominator of two numbers, just call those numbers n and m, it's another number k, where k is evenly divisible by both n and m. That means when you divide k by n or k by m, then you have a remainder 0. And it's the smallest such number for which this is true. And we talked about finding the least common denominator before. And what I'll actually do is I will make a video showing you how that's done so you can go back and review it anytime you wish. Now let's go to these two right here. The least common denominator I just defined. And the term identity refers to a special type of an equation. So an equation is called an identity. It's right here if you want to see. So an equation in the variable x, or whatever variable you have. For example, this equation right here, why is it an equation? Because it has an expression on one side and on the other side of an equal sign. And this is an equation in the variable a. So an equation in whatever variable you happen to have is called an identity if I replace a by any number whatsoever, and I still get a true sentence. And we'll see some examples of those. Some equations have no solutions. So an equation with no solution is an equation where no real number x produces a true statement. So if I have an equation and neither of these are identities or no solution equations, but suppose this were a no solution. No matter what value I choose for b and substitute b for that number and do the computation, it's not going to equal 16. That's what I mean. And we'll see those as they come. So here's the new thing. I'm going to try to use this and in a combination. And we're going to solve some linear equations. So the first thing we're going to solve is going to solve 6a minus, in parentheses, 5a minus 1 is going to be equal to 4. So again, all we do is we use distribution, and what we're going to be simplifying right here first is the minus, in parentheses, 5a minus 1. So if you recall from our last, this is the same as minus 1, and then using distribution times 5a. So that becomes minus 5a. And then using distribution again, minus 1 times minus 1 is a plus 1. And all of that is equal to 4. Now, before we do anything else, we're going to collect like terms. And right here, 6a and 5a are like terms. So 6a minus 5a is just 1a. And you can write 1a if you want, but I'm just going to write a because I'm lazy. So 6a minus 5a simplifies to a. And I have a plus 1 still there and a 4. So our goal is to get a, because that's our variable, on one side of the equation by itself. So what we're going to do is we're going to take the plus 1 and we're going to move it to this side. And the price we have to pay for that move is it becomes negative. So plus 1 becomes minus 1. So that gives me A is equal to 4 minus 1, which is equal to 3. So that's our answer for the first one. So not so bad. So let's look at the second one. Let me give us more space here. So our second one is 4 times 3b minus 1. So if you're watching this at home, one of the niceties of doing this by video is you can literally pause the video right now, and I actually suggest you try to do this and try to work this problem out on your own. And once you're done, you can unpause the video and watch how I work it. If you feel really confident, you can fast forward. You've got all of those options. I'll never know the difference. And to be honest with you, these videos are optional. My Math Lab provides videos for you to watch as well. You can pick and choose and do whatever you want. Just let me know if you have problems. I'm just here to help. But let's go ahead and work this one out. Again, we're going to use the distributive property. I'm going to multiply 4 times 3b. So 4 times 3b, and then I'm going to multiply 4 times minus 1, and 4 times minus 1 is minus 4. That was easy, so I just did it. And then I get 16. It's equal to 16. So 4 times 3b is the same as 4 times 3 times b minus 4 is equal to 16. And 4 times 3, that finally gives me 12b minus 4 is equal to 16. So let's come up here. So again, I want to get the b on one side of the equation by itself. So I'm going to move the minus 4b to the other side of the equation. And when I do so, it becomes positive. So that's going to give me 12b is equal to 16 plus 4. So again, we just continue to simplify. That's 12b is equal to 20. And now, if 12b is equal to 20, I want to know how much a single b is. So I divide both sides by 12. That's the same exact thing as multiplying both sides by the reciprocal of 12, which is 1 over 12. So 12 divided by 12 gives me 1b on the left-hand side. And now all I have to do is reduce 20 divided by 12, and they're least to reduce them, I hope you see, that's going to give me dividing 20 by 4 gives me 5, and dividing 12 by 4 gives me 3, and that's my final answer right there. B is equal to 5/3. So let's do the next one. So I have 4z is equal to 8 times 2z. Guess I should do the z's that way. Even more important now that I'm using my Wacom Bamboo tablet, plus 9. So now, remember this is 8. I'm going to use distribution here. So 4z on the left-hand side just stays put. Can't simplify that. But 8 times 2 times z is 16z. Why? Because 8 times 2 is 16, and 16 times z is 16z. And 8 times 9 is plus 72. So here I need to get the z's on one side by himself. So I'm going to take this term, 16z, and I'm going to move it over here in my next step. So the price I have to pay is it has to change signs. So that's 4z minus 16z. And since I moved it, the only thing left on this side is 72. So 4z, simplify the left-hand side, 4z minus 16z is minus 12z is equal to 72. So again, I need to know what a single positive z is. So I divide both sides by the coefficient of z. So I'm dividing by minus 12. Again, I reiterate, this is exactly the same as multiplying by the reciprocal of minus 12, which is 1 over minus 12. And I do that to both sides. And this is going to give me minus 12 divided by 12 is 1, and 1 times z is z. And 72 divided by minus 12 is going to be minus 6. And that's our answer for that. Okay, let's continue on. Whoops. Push the right thing here and move it up. So the next problem, number D, we're going to start out 2 times x plus 8 is equal to 3 times x minus 5. And we're going to use distribution on both sides. So again, you should be getting really, really comfortable with distribution. So 2 times x is 2x. 2 times 8 is plus 16. 3 times x is 3x. 3 times minus 5 is minus 15. So you can do two things at once, but I'll continue to go for just now. I'm going to move my 2x over to this side. So that's going to give me 16 is equal to 3x. And since I want it right next to my x term, it's going to change sign. 3x minus 2x minus 15. So that's going to give me 16 is equal to x minus 15. Why x? Because 3x minus 2x is x. Now on my next step up here, I'm going to take my minus 15 and I'm going to move it to the other side. And when I move the minus 15 to the other side, the price I have to pay is it becomes plus. So 16 plus 15 is equal to x. 16 plus 15 is 31 is equal to x. And I'm done. That's my answer. Okay. Let's do another one. We'll go ahead and work all of these out because you have the option at any time to fast forward these if you feel you've got these ready. For those of you who want to do every single problem, that's the cool thing about me recording them, you actually can go through every single problem with me. There's no skipping. So again, we're going to do number E, and that's 3 times 2a minus 3 is equal to 5 times a plus 4. So using distribution again, three times 2a is 6a, and 3 times minus 3 is minus 9. That's my left-hand side. 5 times a is 5a, and 5 times 4 is plus 20. So I'm going to move the 5a to the other side. I'm going to put it right there next to my 6a. The 5a becomes minus 5a because that's the price I have to pay. And now I'm going to move the 9, the minus 9, to the other side here. So that's going to give me a plus 9 on the other side because that's the price you have to pay to move a term to the other side. So now we're just going to collect like terms. 6a minus 5a gives me a single a. And 20 plus 9 is 29. And that is my solution. Now let's do number F. I've been given 12 times 4c minus 2 is equal to 3c minus 4. In this case, distribution on this side. You see the distributive property is used an awful lot here. So 12 times 4, c is 48c. 12 times minus 2 is minus 24. This is just 3c minus 4. So again, I'm going to take the 3c and move it over here. So that becomes 48c, and my plus 3c becomes a minus 3c. And then I'm going to take my minus 24 and move it over here. So minus 24 becomes plus 24, and it joins my minus 4 that is already over there. So now all we have to do is combine like terms. So 48c minus 3c is 45c. And 24 minus 4 is 20. So I know what 45c is. 45c is equal to 20, but I want to know what 1c is. So again, the coefficient of my variable c is 45. So I multiply both sides by 1 divided by 45, which is the same as dividing both sides by 45. And I get c is equal to 20 divided by 45. And of course we want to reduce that, and we can do it because both sides is divisible by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. So my answer, my preferred answer, is C is equal to 4/9. Okay, let's see what else we have. Whoops. Oh, that's kind of cool. This is the first time I've actually used this method, and I think it seems to be working pretty nicely. So let's get some more space to draw. Whoops. Whoops. There is an erase button, but it doesn't work very well. So here, what we're going to do is we're going to clear fractions. And this is the most important thing you can learn. And at this first part, clearing fractions is going to be pretty easy. But let's look at number A. Not that way, though. There we go. And we have y, this is an equation in the variable y divided by 6 minus 4 is equal to 1. Now we could just go ahead and solve this exactly as it is, but I don't want to deal with that fraction, and I doubt you do too. So what we do is we're going to clear denominators. So I know if I multiply both sides by the same number, that's the multiplication principle of equality, I'm going to get an equivalent equation. So what I'm going to do is I'm going to multiply hold on. I'm going to multiply both sides by the denominator, which is 6. So it's very important that you're going to be multiplying both sides by 6. 6 on this side and 6 on this side. Whoops, there it is, 6. So 6 times y divided by 6 is the same as 6 divided by 6 times y. That just leaves me a y. 6 times minus 4 is minus 24. So all I did is I just distributed the 6. I multiplied the 6 times both of those terms. And 1 times 6 is equal to 6. Wow, that made it a lot easier, because now to solve it, all I have to do is move my minus 24 to the other side, because then I'll have y by itself. That gives me y is equal to 6 plus 24, or y is equal to 30. So the general procedure is when we have equations with fractions, if there's only one fraction, we multiply both sides by the denominator. If there's two fractions, then we multiply both sides by the LCD of the denominators. And that's exactly what we're going to do next. So let's do this one. So I have 1/4 x minus 3/8 x is equal to 5. So we ask ourselves the question, what is the LCD of 4 and 8? Now I know it's been 2 weeks since I've seen you, and you're seeing me, but I'm not seeing you. But we know that the LCD of two numbers is always greater than or equal to the largest of the two numbers, and it's equal to the largest of those two numbers, in this case 8, if the smaller of the two divides it. So the LCD is equal to 8. I'm going to try something here. I don't like that. I'm going to see if I can erase it. Does erasing work? Ah, erasing works. Okay, cool. I'm learning. Okay, so I'm going to multiply both sides by the LCD of 4 and 8. So literally, I'm going to do 8 times 1/4 times x minus 3 divided by 8 times x. You have to multiply everything by 8. Now I'm just going to use the distributive property. So literally all I'm doing here is, if you want, this is the pen I use, and it has this little thing right here. If I push it, that means I can move the screen around, and it's kind of in a bad place for me, so I'm always wanting to push it. So I'm using distributive property. 8 times 1/4 x is the same as 8 times 1/4, or 8 divided by 4 times 1 times x. So 8 divided by 4 is 2. 2 times 1 is 2, times x is 2x. 8 divided by 8, so now I'm doing 8 times minus 3, 8's x. So 8 divided by 8 is 1. 1 times minus 3 is minus 3, times x is x. And 8 times 5 is 40. So now, the whole point of doing this whole process is called clearing denominators. It's something that I harp on all the way to college algebra. And we spend a lot of time, at least in my class, learning how to clear denominators in intermediate algebra, because students come into that class from all walks of mathematical backgrounds. Let's go ahead and finish solving this. And what I just did from this equation, which I can call equation 1 and equation 2, they're equivalent in the sense that the value of x that makes equation 1 true is the exact same value of x that makes equation 2 true. But equation 1, after I cleared the denominators, I get equation 2 that has no denominators whatsoever, and it's much easier to work with those. So 2x minus 3x is minus x, and that's equal to 40. But I want to know what plus x is, and there's 2 or 3 different ways you can find plus x, but the easiest way is just to multiply both sides by minus 1. So minus 1 times minus x gives me plus x. And minus 1 times 40 gives me minus 40. Okay, not so bad. So let's see about the next one. So here we go. It seems much harder than it's going to be, but you have to be careful. Minus 6x plus 5 over 4 plus 1 is equal to minus 5x over 4. So we need to find the LCD, but it's easy because we only have one numerator and it's 4. So the LCD is 4. So we literally are going to multiply both sides by 4. So here, 4 is going to be multiplied by this first term and then this second term. So 4 times minus 6x plus 5 divided by 4 is the same as 4 divided by 4, which is 1, times minus 6x plus 5. So that gives me minus 6x plus 5. Then 4 times plus 1 is plus 4. Over here, I'm multiplying 4 times this term. So 4 times minus 5x divided by 4 is the same as 4 divided by 4, which is 1, times minus 5x. So I just get minus 5x. And notice from equation 1 to equation 2, I have a clear denominators. And these, again, these two equations are equivalent. Whatever value of x makes equation 1 true, also makes equation 2 true. So here, let's go ahead and simplify first. So we've collected like terms just by the way it came out. So this becomes minus 6x plus 9 is equal to minus 5x. So give me some more room here. No. There we go. So, I think what I'm going to do is I'm going to leave the 9 where it is, and I'm going to move the minus 6x to the other side. So the 9 stays where it is, and the minus 6x goes to the other side and becomes plus 6x. So I have 9 is equal to minus 5x plus 6, and notice that this is exactly the same as 6x minus 5x. So 6x minus 5x, or minus 5x plus 6x, gives me x. And I just solved equation C. Not so bad, right? So now let's look and see what happens when we get decimals. And decimals really are not so bad. They look nasty, and they are nasty if you try to solve them without using the techniques I'm getting ready to show you. So let me get a free space here. Okay. So we're going to do D, and I have 0.05x plus 0.06 x minus 1,500 is equal to 570. So here is going to be our trick. I want to change my decimals so that these are whole numbers. And I can get them to be whole numbers by moving the decimal 2 places to the right. And since basically what I'm doing is I'm multiplying both sides by 100. So that's going to give me 5x plus 6 times x minus 1,500. And here I have to move the decimal 2 places to the right 2. So that just means I add 2 more zeros. Now all I have to do is literally give myself some more room. I have to use distribution right here. 6 times x and 6 times minus 1,500. So this is going to give me 5x plus 6x. And 6 times minus 1,500 is, goodness, I best not do this. Come on. Let's do it over here. I have room. So zero, 6 times 5 is 0, 3. 6 times 1 is 9,000. And since it's minus 9,000. That's usually what happens when you move decimals. You have to deal, the price with moving decimals is I get nice little, I don't have to do any decimal division. So 6x and 5x is 11x. And clearly I'm going to move this term to the other side. So that's going to give me 5,700 plus, sorry, I'm going to use the eraser here. I need to add an extra 0 there, don't I? So 57,000 plus 900. Sorry, 9,000. So that's going to give me 11x is equal to 66. Oh, how nice. 1,000. Why am I saying that's nice? Because that's going to evenly divide by 11. So I have to, no matter what, divide both sides by 11. And x is going to be 66 divided by 11 is 6. 1, 2, 3 zeros. Okay. Let's go up and do the next one. The next one's really much easier. Let's do number E, which is 0.4 times x plus 7 minus 0.1 times 3x plus 6 is equal to minus 0.8. So again, I just want to move these decimals over 1. So be careful here. This is the equivalent of multiplying both sides by 10. So that's what I do. When I move the decimal to the right by one place, I'm multiplying both sides by 10. So this is going to give me 4 times x plus 7. This is going to be minus 1 times 3x plus 6. And this is going to be equal to minus 8 because I moved the decimal place 1. So now it's just distribution. 4 times x is 4x. 4 times 7 is 28. Minus 1 times 3x is minus 3x. And minus 1 times 6 is minus 6. All of that is equal to minus 8. So again, let's collect like terms. I get a 4x minus 3x plus 28 minus 6. I think it's helpful to collect and simplify before I move anything across the equal sign. So 4x minus 3x is x. 28 minus 6 is plus 22, and that's equal to minus 8. So x, moving the 22 across the equal sign, is minus 22 minus 8. So that gives me x is equal to minus 30. I think that may be our last one. No, we have to do two more good ones. Yeah, we haven't used the concept of identity or no solution yet. So there we go. So remember, let me give you the definitions again. An equation, remember equations have equal signs, is an identity. If every real number, and I'm just going to pretend our equation is in the variable x, results in a true statement. And an equation has no solution. We say equation has no solution, and it's obvious, right? That means no value of x works. That's really informal, but you get the drift. So let's go ahead and see which of these two these examples are. So I have six times z plus 7 is equal to 6z plus 42. So let's use distribution. 6 times z is 6z, and 6 times 7 is 42. Is equal to 6z plus 42. So I'm going to move the 6z over here. That's going to give me 6z minus 6z plus 42 is equal to 42. That's going to give me 0, because 6z minus 6z is 0, plus 42 is equal to 42. Or in other words, 42 is equal to 42. What? Of course. That's always true. So when you get a solution, when you're solving an equation, and you get some conclusion like 0 is equal to 0, 42 is equal to 42, x is equal to x, 3x is equal to 3x, etc. All of those signal that this is an identity. Why? Because you literally have the exact same number or the exact same symbol on both sides of an equation. And that means all values of x work. So let's do this last one. And we will do 3 plus 12x minus 1 is equal to 8x plus 4x minus 1. So again, simplify. That's 12x 3 minus 1. So I'm 12x plus 3. So in other words, I'm collecting like terms, is equal to 8x plus 4x minus 1. So this gives me 12x. 3 minus 1 is plus 2. And 8x plus 4x is 12x minus 1. So now I'm going to move my 12x to the other side. That's going to give me 12x minus 12x plus 2 is equal to minus 1, which results in, that's supposed to be an x there, 0 plus 2 is equal to minus 1, which is the same as 2 is equal to minus 1. What? No way. That's always false. So this is an example of an equation that has no solution. Equations which have no solutions are equations that reduce down to some number m is equal to some m, where this is actually false. For in our case, we had 2 is equal to minus 1, and that's false. So when they reduce down to something like that, your conclusion is the equation has no solution. Okay, so that's it for 9.3, and I hope you enjoyed it, and just keep on studying. I'm looking at the wrong camera. Keep on studying.